So here we go on our next podcast, and thought I'd try something a little different. Now, I'm traveling. Welcome to the hotel room. Let's see, out here it's heading down towards minus 5 degrees Fahrenheit, which is really cold because I've already met that in the mountains on the way where I am. So, in any case, last week I was turned on to something by some folks in our group. Bob Latino, who I work a little bit with on Reliable Magazine as one of the editors. So discussion came up about NotebookLM, which apparently has been out for a little while. So there were some examples up where it will take materials you upload and convert that over to a podcast. So I went ahead and I put it through the paces a little bit. So this one here, this is the one that comes with it. Let's get rid of that because I really don't care. These are the ones I uploaded. So electrical signature analysis was my attempt at overloading it. And apparently I did really good because it does a pretty good job. As a matter of fact, I came off kind of sounding a little negative, but really, let's go ahead and load the conversation, and I should be all set so you can hear what it says. And it basically took my electrical signature and current signature analysis book, a bunch of IEEE papers I did on wind turbines, and a few other things that I threw at it, and came up with a summary. These sources describe electrical signature and motor current signature analysis techniques for predictive maintenance of electric machinery. It says particularly in wind turbines and pumps. Well, that's because I overloaded it with wind turbines and pumps. So that was one of the things. So it's like with any, we're calling it AI, right? So with any machine learning system, it's going to take what you feed it and it's going to bias itself towards that. Now, what I found was interesting, and I found this also with ChatGPT search, is it doesn't just kind of work off of what you give it, because apparently it went off into outer space and grabbed some materials and came back and embedded that discussion in particular when it was talking about the book. Now, the last chapter of the book, I talk about machine learning and AI in the electrical signature and current signature space. It's not particularly flattering based on our experiences in what we did with it. So, however, when it went off into space, it got information, and I was able to trace where it got it from. It was from an AI machine learning ESA systems website, and it introduced that as if that was my position, which it is not. So I'm into expert systems and the like. So we do use AI, we do use machine learning, but they supplement the expert system, not the other way around, right? So we prefer the expertise, the knowledge of the machines, not an anomaly detection device or a power quality device pretending to be electrical signature analysis. And if you're one of those listening to this and I upset you or I hurt you, too bad, so sad. So anyways, in here, that was kind of mean, wasn't it? So in here, this one's the first one. Now, on the other hand, what was really interesting was it gave some insights onto the materials. So I'm just going to show you real quick. These will be attached to the blog. So
welcome back, everybody. Excited to jump into another deep dive today. And today we're going to be talking about electrical signature analysis.
Sounds good.
Or ESA, as I'm sure we'll be calling it. And we have a ton of stuff to cover here.
Yeah.
You guys sent over a really fascinating collection of research papers or articles, even a book chapter talking all about how we can use ESA to pinpoint machinery faults,
Absolutely.
especially in wind turbines. But before we get into the specifics, I always like to get a lay of the land first.
Sure.
Can you give us just a quick overview of what ESA is and what makes it so powerful?
Yeah, so at its core, ESA is really about listening to the electrical heartbeat of a machine.
Okay.
We're using electrical signals to tell us about the mechanical health of the system.
Interesting.
And the thing that makes it so powerful is you can diagnose a problem in a wind turbine gearbox, for example, miles up in the air just by analyzing the electricity coming from the generator.
Wow, that's pretty incredible when you think about it.
It is.
I mean, how is that even possible?
It's all about the connection between the electrical and mechanical systems.
Okay.
So any mechanical issue, even a small one, creates a kind of a ripple effect. It distorts the magnetic field inside the machine.
And that's something we can actually measure.
Exactly. And those distortions show up as unique patterns in the electrical waveforms.
It's like a fingerprint almost.
Exactly. Each fault has its own electrical fingerprint.
I'm starting to get the picture here. But when we talk about
So you'll hear the rest of it. I'm going to have these up at the end, each one. So you can hear it already has presented some insights. As a matter of fact, what I learned from this 23-minute thing, other than there were some things that were wrong, but what I learned was some new ways of presenting the material that I'd created, some stuff that makes it simpler for people to understand. So it's a powerful tool for doing a little bit of insight, and it did it as basically a podcast. So I can download it, put it on a USB, listen to it in my vehicle on a road trip, for instance, things like that. It does a lot of other things. It summarizes all the information. So I gave it close to 1,000 pages worth of materials for it to digest. It took about 4 hours to spit out that 23-minute thing. Well, I mean, once you upload it, once you kick it off to do that, you can go away and come back later. But basically, there were some other things in there that weren't the greatest, but it is a Google product. So it went off, and basically what it did is, in the end, there's some stuff there. I'm going to leave everything exactly the way it is so you can hear the exact experience. But it went off and it went to one of the advertisers for the technology and grabbed their stuff and presented it as if that was my position. So, not too worried about it. Y'all know who I am and y'all know my position if you're listening to this. So, that was the first one. Let's go ahead and take a look at something else. So, that was a big, heavy-duty one. The next one, let's go here. This was my dissertation. So it's one document, and it goes through doing an audit. So it went through, and it picked up on a lot. It added some stuff again. However, in this case, because it's something that I did in the past, and it has some relationship with what I do now. The information it brought back that wasn't exactly correct was more or less correct, but from other sources than what I fed it. This becomes important because if you're not aware, Air Canada ran into a problem a few years back and had a heavy-duty lawsuit because the AI that they had trained on their policies had gone off and searched the internet and grabbed policies on the internet and brought those back and was presenting in their chatbot to their customers that those policies that it found on the internet were Air Canada's policies. And the lawsuit in particular came because a lady had a relative pass away, and she had gone to their chat and said, "Hey, how do I get qualified for whatever to do a grievance discount?" And they basically said, take the trip and then turn in the paperwork afterwards, which is the exact opposite, because with Air Canada, their policy was to contact them first, and then they would, make a decision at that point. So they denied it. They made her pay full price, and obviously, that ended up in a lawsuit. And it was from their AI that basically escaped and went out and did other things. So industrial assessments, about I think if I remember right, it's about 250 pages of materials on doing industrial assessments. So let's see what insights it had just briefly. Again, these will each be up at the end.
Welcome to the deep dive. Today we're diving deep into industrial systems.
Okay.
And you've given us a really interesting mix of materials, dissertations, technical manuals, even some government program guides.
Lots to unpack.
Yeah, it's a lot to unpack.
It is, and it's interesting to see all the different angles.
Right.
We've got the pure technical side.
Yeah.
But also some sources that touch on the human element too.
Right.
How these systems impact workers.
Yeah.
And the bigger economic picture is kind of interesting.
It's all connected, right?
Yeah.
Our goal today is to try to figure out how to make industrial settings more efficient,
Right.
more competitive. We're talking about practical stuff,
Uh-huh.
energy audits, cutting down on waste,
Yeah.
getting the most out of those massive motor
Yeah,
systems,
those big motors.
and even a little bit of reliability engineering.
Right.
Not exactly light reading, but definitely important.
It's important stuff, and it's fascinating how these topics are all interconnected.
Yeah.
Okay, so right off the bat, while motors were part of that dissertation, they were not a significant portion. Now, there were things related to, there was a chapter on that, but there was a chapter on steam and compressed air and other things. So this was my novel approach to industrial assessments for energy, waste stream process, and reliability. And it goes into how to calculate everything based upon the work I was doing in the 1990s with the Department of Energy and at the Industrial Assessment, or I'm sorry, it wasn't an IAS at the time, the Energy Resources Center at the University of Illinois while I was teaching industrial engineering. So, very interesting stuff. Again, we'll be at the end. So let's take a look at yet something different yet again. And we've covered these guys here. So let's see. This one here I thought was interesting. So what I did is I took the documents associated with a NIST program that we collaborated with NIST, National Institutes of Standards and Technology, on advanced manufacturing maintenance. So it was looking at the tie of maintenance to management and so on, and all the economic benefits. And at SMRP, we participated in that. I coordinated it, ended up providing a list of my clients, but in any case, made sure that we had SMRP get the credit. So let's go ahead and load it real quick. I downloaded these so I can put them in the chat at the end. So it'll be a long program, but you'll be able to listen to them, whenever you wish, or skip through. I've figured out how to set up chapters now in YouTube, so you'll be able to skip to each one if you're doing this on a computer. So while it's going through, so the survey came back, and what it did is it looked into different types of maintenance: reactive, preventive, and predictive, and so on. It did it again, though, because as a matter of fact, in each of these, like the one for the industrial assessments, while we used modeling, and it wasn't an AI and it wasn't machine learning, it was a rule-based model, the notebook went off and started talking about the dissertation covering AI and machine learning. This was written in 1999. So, yes, AI and machine learning existed. It's part of what I taught at UIC, but I didn't even mention those terms in the document, and it goes on for some minutes. The other thing it did at this point also was it started repeating itself. So it says da-da-da-da, and, thank you for joining us and everything else. And that was about 15 or 16 minutes in, and then it spent the next 5 minutes repeating sections from earlier. I don't know if you're supposed to edit those and bring them back, but if you use this, you want to be really careful that accuracy, because it's biased towards finding something with AI and then going off on a tangent that you probably won't agree with, or you might, and a few other things. It's very, very biased. That's because Google's trying to sell you AI products, right? So you want to be cautious of that.
Welcome, everyone. Ready to do a deep dive with me into the economics of machinery maintenance in manufacturing?
Sounds fascinating.
I know, right? We've got some really great research papers and reports from the National Institute of Standards and Technology.
NIST.
NIST, yeah, to help us really unpack all of this.
I love NIST.
They're great, I know. Get ready for some really big numbers
Oh, yeah.
and some surprising insights.
Buckle up.
So these aren't real people. These are strictly AI. As a matter of fact, what I did while this was all going on, my team from MotorDocAI, Branka and William, had been working on a musical, basically, having to do with an AI that, it's called Love.exe. And no, I didn't come up with that name. ChatGPT did. So we wanted to create, in several weeks, a complete 2-hour story in music based upon something I'd written within the last few years as part of a creative writing class. Yeah, I do that too in order to practice writing and come up with new ways of communicating. So use that storyline and put it in about we told the software that creates the music in 200 characters for each song the storyline, and we said, okay, at this point we're going to have the hacker that's creating this AI. He's working late, he's making mistakes, and one of his lines of code generates consciousness, in this AI, that he's given it a female personality. And then there's another hacker who creates a male personality and somebody she just talks to. So, the one escapes, nothing wild, just he gets off because, and starts doing stuff because of his programming. And the hacker tool that has gained consciousness, she's the heroine of the story, takes off and has a quandary, lets her creator know that she exists. He tries to destroy her. She finds out he has other things going on, gets jealous, crashes his systems, runs into the other AI. They get together and they take vengeance on everything basically, and then they let humanity know. Humanity reacts badly, that kind of story. And so from the point of view of the AI, creative writing project. So always look from the other point of view. All of it done in AI, all of it done in machine learning. Even the editing I did was all done. The final bit where I pasted it together, that's the only thing that was manually done. Everything else was done through computer. Basically the singers, the music, everything, AI personalities. So we come to this and we have a pair of podcasters, basically.
Yeah, buckle up.
You are going to be shocked by how much money is tied up in keeping machines running smoothly.
I bet.
A 2016 NIST study found that maintenance costs plus the losses that could have been prevented actually totaled a staggering
Go on.
$193.6 billion. Billion.
Wow.
Now that's standard manufacturing, not including oil and gas, mining, steel, and everything else. That's just regular manufacturing. So the number actually gets up closer to several trillion in losses, in lost sales and everything else, the impact on the GDP. So, but that's right from the study. It was done by an economist and his team. Very, very good information. So, in the end, it goes off on a tangent about AI again. And while they talk about predictive analytics, it really, that's not the focus, but it spends a lot of time pretending like that's the real focus of the paper. Let's see if I can find something along that.
0.7%, we're still heavily reliant on RM.
Wow, that's a lot of companies potentially must be more like a company that builds custom furniture based on specific customer requests.
Tasks.
Right, it just doesn't become a priority.
Yeah, it gets lost in the shuffle.
Do you think it's possible that in these situations, employees might be prioritizing other tasks and pushing maintenance to the back burner until a problem forces their hand?
Oh,
I think that's very possible. Yeah, it highlights.
it took a different tack. Okay, so part of what it said was employees, the employees and the maintenance staff are the ones holding back the implementation of maintenance, not corporate decisions.
The importance of clear communication and leadership.
Together.
I agree.
We're not replacing humans with machines. We're equipping
Deviations that might signal a developing issue.
So it's like creating a digital thing.
Is that in these delegative environments, there might not be enough oversight or guidance when it comes to those maintenance tasks.
Right, it just doesn't become a priority.
Yeah, it gets lost in the shuffle.
So because the employees don't give it a priority, we need to automate things. That's its position. That is not, absolutely not in the study.
Do you think it's possible that in these situations, employees might be prioritizing other tasks and pushing maintenance to the back burner until a problem forces their hand?
I think that's very possible. Yeah, it highlights the importance of clear communication and leadership, even in workplaces that value employee empowerment.
So it's a delicate balancing act,
It is.
empowering employees while ensuring that those critical tasks like maintenance don't get neglected.
100%.
And this brings us back to our discussion about transitioning to PDM.
It does.
Are you ready to explore the steps involved in
Predictive
making that
maintenance
shift?
is
Yes,
only it.
let's do it. Yeah, let's dive into those practical steps.
Okay, so what does this transition to PDM actually look like?
Yeah.
Where do companies even begin?
Well, the NIST researchers outlined several key areas to focus on. First, you need to figure out what data is crucial for predicting potential failures. This could include things like temperature readings, vibration patterns, pressure levels, or even the sounds a machine makes.
It's like those old school mechanics, who can pinpoint an engine problem just by listening to it.
Exactly, except now we're not solely relying on human senses. We can use sensors to gather that data continuously and with much more objectivity.
Okay, so you've outfitted your machines with sensors, and you're collecting all of this data. Now what? How do you actually make sense of it all?
That's where the data analysis and modeling come in. So you need to establish those baseline readings for each machine when it's operating normally.
Not in the study. So it goes off. And now it's saying you have to replace the employees who are the problem with maintenance not happening with automation. So basically it just turned into a sales thing for AI, these AI companies. So as in, replacing people with, the magic dust. So last one, which I also thought was very interesting, I said, okay, I want you to go, and I had it listen to my last vlog on the Empower tool. I had it looked at 3 of my websites, the Empath CMS, the MotorDoc website, and the MotorDocAI website, and say, basically give me some insights. And first off, it calls me a founder. I am not a founder. I'm the president of the company. I created the company, yes, but founder implies very specific things. We receive no funding from anybody other than our customers. We self-fund everything. So we go out and work, and we sell products. That comes in, and half of our profit goes back into research and development and doing other things to help the industry. I know the new business model is go out and find somebody to hand you a bunch of cash so you can explore your idea, but you're locked into that. And I've been repeatedly saying this because I had some uncouth individuals suggest that I needed to turn my business over to them or else. Yeah, didn't work out well for them. So anyways,
All right, so welcome to another deep dive, and today we're diving into a company called MotorDoc LLC.
Oh, interesting.
Yeah, they're doing some really cool things with motor and generator health.
Okay.
And what's really caught my eye is, well, they have their website and product pages like all companies do, but the founder actually has a YouTube vlog.
Wow.
And it's super techy, which, I'm all about.
Yeah, you don't see that every day, that level
Like
of
this
kind
one.
of
This one is super techy.
insider perspective.
Exactly.
This one's kind of fun.
And one of the things that really makes MotorDoc stand out to me is their use of what's called electrical signature analysis.
I left, by the way, at the top
ESA.
of this.
Yes.
I left
And this
address
is,
down there.
think of it as a way to kind of hear the heartbeat of
NotebookLM.com.
your
I
entire
highly
motor
recommend
system,
you try it.
not just like
But remember
isolated
this.
points.
So instead of checking your pulse at your wrist,
Remember this. All of these tools that you get to use for free, okay, so like with ChatGPT, we pay a certain amount, and it's not a lot, it's not a minor amount, in order for them to not use our material to train it, and we have to trust that they're not doing it. This, it's Google. That means whatever you upload is going into their training. Okay? I did review the terms and conditions. So I didn't put any company-specific information. So do not take anything you don't want to get out into the wild. Don't upload that into any of these tools of this type. It's bad enough that the newer versions of your operating system are spying on you and using your information to train. And don't tell me I'm a conspiracy theorist. It's true. Read it. It's there, meaning that it's in the news. It's in all of the cybersecurity stuff I'm involved in and everything else. Everything I'm doing right now in here is being used to train through Microsoft. If I'm using Windows 11, they basically get to see a continuous stream. So in any case, enjoy. So.
you're listening to the whole cardiovascular system.
Exactly.
Okay.
You got it. So,
Yes,
so
sir.
traditional methods, things like accelerometers, they're
So-
signals to this massive database, and it helps them to pinpoint, specific bearing, very subtle issues that other systems
to this.
just they miss.
Okay.
Yeah.
So like they're listening with a superpowered stethoscope.
That's a great way to put it.
What kind of issues are we talking about though, and why should I care about those the super high frequencies?
So think of superharmonics, like these tiny whispers.
Supraharmonics are an individual condition that we look at with the Empower. It's not something that's used for all the other stuff they're talking about. So they made an error here, but they do something else that's unconscionable, because the technology we have is a rules-based technology, and it resides on your machine based on, and the alarms are set based upon rules. They literally had gone out to one of the AI sites, because I know which one they went to.
Insulation breakdown,
Oh wow.
even problems in connected components like gearboxes, and even, believe it or not, the blades.
Wow.
And they can do this long before those things become major failures.
Okay.
And for you, that means less downtime, lower repair costs, and a safer overall
See,
operation.
good stuff.
That's impressive. And I noticed they have this huge database of bearing information.
Yep.
Built right into the software.
Right.
Over 83,000 entries, it said.
It's amazing.
So what's the purpose of that?
It's like a fingerprint library for bearings.
Okay.
Right?
So when Empower analyzes a motor, it compares the signals to this massive database.
No, it does not. You use that database to find your settings for that specific bearing, and you enter that in. Same thing with Empath. Empath has about 61 to 63,000. The Empower has about 83,000, because it's a database I've been collecting since the end of the 90s. But it's acting like this is AI. I use AI for anomaly detection when you use our cloud system,
And it helps them to pinpoint specific bearing types and really identify any potential issues very specifically. It's a level of detail you just wouldn't get with traditional methods.
So they're serious about data. Yeah, I can see that. Yeah. And from what I saw in the vlog, they're not just like analyzing the data, they're using it to develop some really, really specialized features, especially for wind turbines.
Absolutely.
What caught your eye there?
Well, I think, by the way.
I think what's really interesting is their focus on making continuous monitoring a reality for wind turbines.
Right.
It's a big challenge.
Yeah.
Because of just the logistics of getting up to the nacelle all the time. But they're already doing periodic testing.
Okay.
So they're gathering data at set intervals, even in those hard to redo. They used to have a simple AS scoring system that industries are facing.
Yeah.
And they're not just selling products. They're actively shaping the future of the field.
Right.
Through their involvement in standards development and workforce training.
Yeah.
So that they got by going somewhere else, because that information was not on any of the websites. And that is literally my position on things. So they found something somewhere that talked about that. So what I thought was interesting was, I thought, based on their description, was they were going out and they were just working off this. But apparently, whether they say they are or are not, it is going out and it's getting other stuff. And often that other stuff isn't particular. As a matter of fact, you see down here, NotebookLM can be inaccurate. Please double check its responses. So as I talk about with all of these tools, don't trust and validate. So basically, if I were to use this for a blog, and I might actually use this particular one, I might use this, take it and edit it and put it up on the website. So there's a description by some podcasters about about MotorDoc, MotorDocAI, our technologies, and specifically, my position on things, because they hit a lot of that. You can go in this interactive mode, you can go in and edit. So you can manually do a lot of the stuff. Excuse me, it's just pretty cumbersome. Now, in the meantime, I created a bunch of these notes and everything else. All of this stuff I can use for getting data on marketing, feedback on what people see when they look at the websites and interact with us, things like that. So it provides some insight that I can use if I use it intelligently. Now I can also take this, toss it into another AI, and really make a mess of things. But just keeping it here and listening and paying attention to it, and sending it out to get stuff, because this is the one where you can go in and you can add your sources. That includes now YouTube. Not the video, not the sound, but if you have allowed it to do the, if it's created the text with it, great. You can cut and paste text in there, and you can go into Google Docs or Google Slides. I don't use either one of those. It's, of course, telling me what my limit is, and I can improve that just by deleting stuff. But, and then when I'm done, I can literally just download it. So, right here I can say, okay, I want to download that, and then it comes down as a WAV file, and that WAV file I can do. Now over here, at some point it had ended, and right now, this last bit here, it's just basically regurgitating the same thing it said earlier, using some different nuances, some different tones, and changing a couple of things. So there's sections in here I might be able to edit and move back into those areas where I have found any errors. So in any case, that is kind of it for this. Really, really powerful tool. I really enjoy it. I'm going to be using the heck out of it, especially seeing as it's free. Well, free as in it's going to take my information to train itself, but free nonetheless. And utilize it for different things, and maybe even to enhance what we're doing here with the blog. So next week, I'm actually going to be talking about what I'm up here doing. We're going to take a look at what happens in a cryptocurrency site in harmonics. So that's interesting because I have no idea. This is the first time we're applying our supra-harmonic capability with the Empower along with the empaths. Well, we've done the empath system here with the other. I'm testing a new correction device that one of our partners had developed to see if it corrects the problem. And that's about it. So with that, have a great time. Enjoy what follows. If you want to skip through them, I'm going to have them divided into times and chapters. Have a great day.
Welcome to the Deep Dive. Today we're diving deep into electrical signature analysis, ESA for short. We've got a stack of research papers, some really interesting technical articles, even some excerpts from a book on the subject.
Really fascinating stuff.
All to help you understand how ESA works, where it's being used, and why it matters. Kind of like a crash course on all things ESA.
Yeah, and when you get down to it, it can make a huge difference. We're talking big savings and avoiding major headaches down the road by finding problems early.
Okay, so let's start with the basics. When those people hear faults in an electrical system, they think something's completely broken. But it's not that simple, is it?
Right. It's much more nuanced. There's a whole spectrum of fault detection. Like at the simplest level, there's anomaly detection, which is basically just a warning signal saying something isn't right.
Like a check engine light.
Yeah, exactly. Then you have band alarm detection, which gives you a little more information, narrows things down.
But it's still not the whole picture.
Nope. So then you get to the top tier, the really powerful stuff. High-resolution spectral analysis.
Which is the heart of ESA.
Exactly. This is where things get really interesting. It's like having a superpowered microscope for your electrical signals.
So what kind of advantages does that give us? What can we do with that?
Well, with traditional methods, you often don't even know there's a problem until the equipment starts acting up, or even worse, breaks down completely. But ESA, it picks up on the subtlest fluctuations, tiny changes in those electrical signals, the kind of stuff that could be a warning sign weeks, maybe even months before a major failure.
So it's like preventative medicine for your electrical equipment.
Absolutely. You're not scrambling to fix things when they break. You're scheduling maintenance on your terms.
You're preventing downtime, making things last longer.
And potentially saving a ton of money in the process. Thousands or even more.
Well, because ESA basically acts like an expert system.
Yeah, it's using these predefined rules, algorithms that have been proven to work,
Time test.
to pinpoint the specific problem and tell you how bad it is. This is different from some of the newer technologies, AI and machine learning, which often need to be trained on data from existing systems. And those systems may have hidden issues we're not even aware of.
So you're saying ESA has this deeper, more fundamental understanding.
It's like having a seasoned electrician looking at your system, someone who's seen it all, instantly recognizing the patterns in those signals that might mean a loose connection, a bearing that's about to wear out.
The sources actually give some really great real-world examples of that. There was one that caught my eye, the case study with a pump system.
Yeah, that one really shows how crucial ESA can be. This pump had just gone through a standard overhaul, so on paper, everything should have been fine.
Good to go.
Right. But the ESA revealed that there were still problems, some misalignment, issues with the bearings, things they had missed.
So even after routine maintenance, there can be these hidden problems lurking that ESA is able to find.
It's like ESA has X-ray vision, seeing beneath the surface and catching those problems before they snowball into something much bigger.
Which is, again, what makes it so cost-effective.
Absolutely. And there's another case study, this one with a wind turbine. During a routine inspection, they used ESA and picked up on a faulty bearing in the gearbox.
Oh, those are expensive to fix.
Incredibly expensive. But they caught it so early that the repair was fully covered under warranty.
Talk about dodging a bullet.
Right. And that's what we want to emphasize. ESA isn't just about finding problems, it's about making smart decisions, saving money in the long run.
And speaking of wind turbines, the sources go into a lot of detail about ESA and how it's used with doubly fed induction generators, or DFIs.
Which are the most common generators you find in wind turbines.
Right, and they're a great example of how ESI really leverages the physics of play. The sources say that even the tiniest defect in a DFI creates these distortions in the magnetic field inside the generator.
Yeah, and because ESA can analyze those distortions,
It can pick up on a whole range of issues.
oh, absolutely. Everything from worn gears, problems with the bearings, to issues with the generator itself, even damage to the blades.
Wow, so it can tell you exactly what's wrong and where.
And that's crucial, especially because these wind turbines are constantly exposed to the elements, dealing with fluctuating loads.
So continuous monitoring with ESA is really important.
Absolutely. It allows for early detection, and it helps ensure those turbines are operating at peak efficiency.
Okay, this all sounds incredible, but I have to ask, how does ESA actually work? I mean, how do you get all this information from just looking at electrical signals?
Well, it's not magic, but there is some serious science behind it. ESA uses some pretty complex equations and principles.
I'm ready for the deep dive.
All right, well, imagine you're looking at a perfectly still lake, and then suddenly there are ripples. Those ripples tell you that something has disturbed the water.
Something's going on.
Right, and it's kind of like that with ESA. It uses these mathematical models to analyze tiny fluctuations, like those ripples, in the current and voltage waveforms.
And those fluctuations are caused by defects in the system.
Exactly. And just like different things can cause different kinds of ripples in a lake, different defects create unique patterns in the electrical signals.
So ESA can tell the difference between, say, a misaligned shaft and a cracked bearing.
Exactly. Each problem has its own unique signature.
It kind of reminds me of vibration analysis, where you're looking at frequencies and decibel levels to find problems.
You're right, there are some similarities. But instead of using an accelerometer to measure vibrations, ESA uses the magnetic field itself as the transducer.
So you're listening to the magnetic field, not for vibrations.
Yeah, that's a great way to think about it. It's like we're eavesdropping on the machine's internal conversations.
And the sources do a really good job of bringing this all to life, using visuals and specific examples. There's this one image showing a damaged gearbox ring gear and another showing a fractured rotor bar.
It really drives home the point that this is real damage we're talking about.
Yeah, serious stuff. And there's a whole section that walks through how to calculate those specific defect frequencies, like the stator slot defect frequencies and the pole pass frequency.
Right. And this calculations show just how precise ESA can be. It's not just about knowing there's a problem, it's about pinpointing the exact nature of that problem.
Like being fluent in the language of the machine, understanding what it's trying to tell you.
Exactly. And that level of understanding allows you to take the right actions, fix the root cause of the problem, not just treat the symptoms.
Which is what sets it apart from those Band-Aid solutions.
Yeah, ESA is about getting to the heart of the issue.
And it's important to remember that these examples aren't just limited to wind turbines and pumps. ESA can be applied to all sorts of electrical machinery and systems.
Right. Transformers, industrial equipment, even electric vehicles. The versatility is really incredible.
So we've talked about how ESA can find existing faults. But what about predicting future problems? Can it do that too?
That's a great question, and it leads us to some of the even more exciting applications of ESA, which we'll dive into in the next part of our deep dive. Welcome back to our deep dive into electrical signature analysis.
All right, so we've established that ESA is amazing at finding existing problems. But I'm really intrigued by this idea of predicting future issues. How do we even start with that?
Well, one area where ESA really shines is in something called condition-based maintenance, or CBM for short.
Okay, I've heard that term before, but I'm not entirely sure what it means.
It's a pretty big shift from the traditional way of doing things. Instead of sticking to those rigid maintenance schedules, CBM is all about using real-time data to decide when and how to maintain your equipment.
So it's kind of like going to the doctor only when you're not feeling well, as opposed to like having a checkup every month regardless.
Exactly. It's being proactive, strategic, and ESA is a key player in that approach because it gives you that real-time insight into how healthy your electrical equipment is.
So instead of just guessing when a motor might need attention, you can use ESA to actually track its condition and know for sure when maintenance is necessary.
Precisely. That means less downtime, lower maintenance costs, and you're not replacing parts that are still good.
Working smarter, not harder.
Exactly. And this data-driven approach, it's only becoming more important as industries try to find ways to be as efficient as possible.
Now, the sources also mention something called remaining useful life, or RUL. It sounds kind of sci-fi, to be honest.
It might sound futuristic, but RUL is quickly becoming a reality thanks to ESA and data analytics.
So we're talking about actually predicting how much longer a piece of equipment is going to last.
That's the idea. By analyzing historical ESA data, we can actually develop models that predict the remaining useful life of things like motors, generators, all sorts of critical equipment.
Wow, that's pretty incredible. It's like having a crystal ball for your machines.
It's not magic, but it feels pretty close sometimes. By knowing the RUL, you can plan for replacements in advance and avoid those catastrophic failures that can shut everything down.
It's like knowing when to retire a racehorse before it breaks a leg on the track.
That's a good analogy. And just like a seasoned trainer can spot those subtle signs that a horse is wearing down, ESA can detect tiny changes in the electrical signals that tell us a component's nearing the end of its life.
So we're not just reacting to problems anymore, we're anticipating them, getting ahead of the game.
Exactly. Moving from reactive maintenance to proactive maintenance.
Now, I know we can't talk about the future of ESA without mentioning artificial intelligence, AI. It seems like AI is finding its way into just about everything these days.
AI is definitely a hot topic, and for good reason. It has huge potential to take ESA to a whole new level.
So ESA on steroids.
You could say that. By combining ESA data with AI algorithms, we can create systems that not only diagnose problems they learned from experience, make intelligent predictions.
So it's like having an ESA expert who's constantly learning, getting better over time.
Exactly. AI can help us analyze massive amounts of data, identify patterns that humans might miss, and ultimately make even better decisions about how we manage our electrical systems.
Can you give me an example of what that might look like, practically speaking?
Sure. Imagine an AI-powered ESA system that's constantly monitoring a motor. It could learn that motor's normal operating patterns and then instantly alert you to any deviations. It could even predict when a specific component is likely to fail and recommend preventative maintenance.
That would be a game changer for so many industries.
Absolutely. Think about manufacturing plants, power grids, transportation systems. Any place where reliability is critical, AI-powered ESA could prevent costly downtime, optimize energy consumption, even make our infrastructure safer.
It's like having a guardian angel looking over all your electrical systems.
And the best part is we're only just beginning to scratch the surface of what's possible. As AI technology evolves, I think we're going to see even more innovative applications of ESA emerge in the coming years.
It's a pretty exciting time to be involved in this field.
It really is. We're witnessing a convergence of technologies that's going to revolutionize how we interact with and manage our electrical systems.
Now, earlier you mentioned that ESA uses some complex equations and principles to do its thing. Can you break that down a bit further?
Sure. At the heart of ESA, it's all about analyzing those electrical signals, looking for patterns, for deviations that could indicate a problem. These signals are essentially waves. They have specific frequencies and amplitudes.
Okay, so far so good.
Now, different types of faults will create unique distortions in these waves. For instance, a bearing that's starting to wear out might generate a signal with a higher frequency than a healthy bearing.
So ESA is basically listening for those telltale signs in the electrical signals.
Precisely. And to do that effectively, we need to understand the physics, the math behind how these signals behave.
That sounds pretty complicated.
It can be, but
Yeah.
the key is to break it down into pieces. For instance, one of the fundamental concepts in ESA is something called the pole pass frequency, or PPF. And what exactly is that? Think about an induction motor, which is a real workhorse in most industrial applications. The rotor, the spinning part, has magnetic poles, and the stator, the stationary part, also has poles.
Okay, I'm picturing it.
Now, every time a rotor pole passes a stator pole, it creates a little fluctuation in the magnetic field.
Like a little magnetic blip.
Exactly. And the frequency of those blips, that's what we call the pole pass frequency.
So ESA is listening for those blips, those PPF signals.
Yes, and any deviation from the expected PPF can be an early warning sign of a problem. For example, if a rotor bar is cracked or broken, it will alter the PPF, creating a distinct signature that ESA can detect.
So it's like a change in the motor's rhythm.
That's a great way to put it. And by analyzing the PPF and other characteristic frequencies, ESA can pinpoint problems with incredible precision.
I'm starting to understand just how powerful this technology is.
And we've really only scratched the surface. There's so much more to ESA, and it's constantly evolving.
Yeah, I'm definitely eager to learn more.
Great. In the final part of our deep dive, we'll explore some of those less obvious applications of ESA and how it can go beyond just fault detection.
We're back for the final part of our deep dive into electrical signature analysis. We've talked about how ESA can find existing problems and even predict problems in the future, but are there any less obvious applications?
Oh, absolutely. ESA is incredibly versatile, a really powerful tool. One area where it's really valuable is in something called variable frequency drives, or VFDs.
I've heard of VFDs, but I'm not exactly sure what they do.
Think of them like the control centers for modern motors. They let you adjust the speed and torque of a motor with a lot of precision.
I see.
You find them everywhere. Industrial machinery, HVAC systems, even in electric vehicles.
Okay, so why is ESA so important when it comes to VFDs?
Well, for one thing, ESA can help make sure those VFDs are set up correctly right from the start.
From the get-go.
Yeah. During the commissioning process, you can use ESA to fine-tune those VFD settings.
Make sure everything's dialed in.
Right, making sure it's delivering the right voltage and frequency to the motor.
Optimizing performance right out of the gate.
Exactly. But it doesn't stop there. ESA can also be used to monitor the VFD's performance over time, make sure everything's running smoothly.
Keep an eye on things.
Yeah, and catch any potential problems before they become major headaches.
Like a continuous checkup for your VFD.
Right. And here's something else that's really interesting. ESA can actually help identify winding stress that's caused by the VFD itself.
Wait, so the VFD can actually damage the motor?
It's possible, yeah. VFDs use these pulse waveforms to control the motor.
Okay.
And those pulses, well, sometimes they can create these high-frequency voltage spikes. And those spikes can actually stress the motor windings, the insulation.
So it's like the VFD is sending these little electrical shocks to the motor.
Yeah, that's a good way to think about it. And over time, that stress can lead to insulation breakdown, and then you've got premature motor failure.
But ESA can detect those stress patterns before any serious damage happens.
Exactly. It's an early warning system for your motor windings, telling you when it's time to adjust those VFD settings or take other preventative measures.
So it's like ESA is really good at playing defense, preventing problems before they even have a chance to start.
It is, and that's why it's becoming so essential in industries where reliability and uptime are critical.
Makes sense.
Yeah.
What are some of the industries that are really embracing ESA?
Oh, just about all of them. Manufacturing, power generation, transportation, building management systems, even renewable energy.
Wow, it's a pretty broad range.
Yeah. Anywhere you've got critical electrical equipment that you can't afford to have fail, ESA is becoming the go-to solution.
So we've talked a lot about the practical applications, but what about the future of ESA? What are some of the exciting things you're seeing on the horizon?
Well, one area I'm particularly excited about is the integration of ESA with artificial intelligence.
AI, it seems like it's everywhere these days. How is it changing the game for ESA?
The potential is huge. You see, ESA generates tons of data, and AI is really good at making sense of all that data. By combining ESA with AI algorithms, we can create systems that can not only diagnose problems, but they can also learn from past experiences and make predictions with even greater accuracy.
So it's like having an ESA expert who's constantly learning and getting better.
Exactly. AI can also help us identify those subtle patterns in the data that humans might miss. This opens up a whole new level of insight into the health and performance of our electrical systems.
Can you give me an example of what that might look like, practically speaking?
Sure. Imagine an AI-powered ESA system that's constantly monitoring a wind farm. It can analyze all the data from all those turbines, learn the normal operating patterns, and instantly alert operators to any anomalies.
Wow.
It can even predict which components are most likely to fail and recommend preventative maintenance, potentially saving millions of dollars in downtime and repairs.
That's pretty incredible. It's like having a crystal ball for your entire wind farm.
And that's just one example. The applications of AI-powered ESA are really limitless. I think we're going to see some really groundbreaking advancements in the years to come.
It sounds like it's an exciting time to be involved in the field of ESA.
It really is. We're at the beginning of a technological revolution, and it's going to be amazing to see where it takes us.
Well, I know I've learned a lot today. ESA is clearly a game changer when it comes to managing and maintaining electrical systems.
I'm glad to hear it. If there's one thing I hope you take away from this deep dive, it's that ESA is a powerful tool that can help you save time, money, and avoid headaches.
It's definitely given me a whole new perspective on the importance of those electrical signals.
Remember, those signals are telling us a story, and ESA is the key to understanding that story.
I think you've convinced me. I'm ready to start listening.
That's great to hear.
And thanks for taking the time to guide us through this fascinating world. I'm sure our listeners found it just as insightful as I did.
It was my pleasure.
That's it for our deep dive into electrical signature analysis. Until next time, keep exploring, keep learning, and keep diving deep.
Welcome to the deep dive. Today we're diving deep into industrial systems.
Okay.
And you've given us a really interesting mix of materials, dissertations, technical manuals, even some government program guides.
Lots to unpack.
Yeah, it's a lot to unpack.
It is, and it's interesting to see all the different angles.
Right.
You know, we've got the pure technical side, but also some sources that touch on the human element, too.
Right.
How these systems impact workers.
Yeah.
And the bigger economic picture, It's kind of interesting.
It's all connected, right?
Yeah.
Our goal today is to try to figure out how to make industrial settings more efficient,
Right.
more competitive. We're talking about practical stuff,
Uh-huh.
energy audits, cutting down on waste,
Yeah.
getting the most out of those massive motor systems.
Yeah, those big motors.
And even a little bit of reliability engineering.
Right.
Not exactly light reading, but definitely important.
It's important stuff, and it's fascinating how these topics are all interconnected.
Yeah.
For instance, one of the dissertations actually argues that the traditional way of doing energy audits is too narrow.
Okay.
Just focusing on reducing kilowatt hours, that's all they look at.
So what are they suggesting instead?
The author is proposing something they call complete industrial assessments.
Okay.
It's kind of a mouthful.
Yeah.
But the idea is to integrate energy efficiency with other things too.
Okay.
Waste reduction, process optimization,
Yeah.
even reliability.
You're looking at the whole system
The whole system, yeah.
instead of just the individual part.
Not just individual parts, that's right.
It's like trying to tune up a car.
Yeah.
You can't just focus on the engine. You got to make sure
Everything's working together.
all the systems are working together.
Exactly. And this dissertation actually walks us through 4 different case studies
Yep.
to show how this approach works in the real world.
What kind of case studies?
Well, they looked at a confectionery company,
Okay.
a power plant, a bakery,
Interesting.
and a grain miller.
We'll definitely have to dive into those later.
Sure.
But first, let's talk about energy audits.
Okay.
We've got some information here about programs,
Uh-huh.
like the U.S. Department of Energy's Motor Challenge
Okay.
and Steam Challenge.
Sounds pretty intense.
Yeah, pretty intense.
They're comprehensive programs.
Right.
It's important to remember that energy savings aren't just about lower utility bills.
Right.
A more energy efficient facility is often a more productive and competitive one.
So it's not just about saving money.
Not just saving money, no.
It's also about improving performance.
That's right.
Interesting.
When you reduce energy waste, you often streamline processes
Okay.
and improve equipment performance at the same time.
So it's like a ripple effect.
Yeah.
One improvement can lead to a whole bunch of other positive outcomes.
Exactly, a cascade.
Cascade, yeah.
Speaking of improvements,
Yeah.
one of the documents you shared, industrialassessments.pdf,
Mm-hmm.
is full of interesting energy-saving tips. Some of them are surprisingly simple.
Like what? I'm all ears for easy wins.
One example that jumped out at me was about replacing drive belts.
Drive belts, okay.
Yeah, it turns out those seemingly insignificant belts can be major energy hogs.
Really?
By switching from standard V belts to something called cogged or HTD belts,
Okay.
you can reduce energy loss by up to 6%.
6%. That's pretty significant just for swapping out a belt.
It is. It is.
Wow.
And it gets you thinking, what other easy upgrades are out there
Right.
that people might be overlooking?
Yeah.
The document highlights a bunch of them,
Okay.
like using synthetic lubricants,
Uh-huh.
making sure equipment is properly insulated,
Yep.
even something as basic as turning off equipment when it's not in use.
Oh, the old turn it off if you're not using a trick.
Yeah, it's amazing how often that gets overlooked.
Absolutely.
It's like finding hidden treasure in your own factory.
I like that.
Yeah,
I'm starting to see how these assessments can really pay off.
they can. They can.
Okay, cool.
And it's not just about finding those quick wins.
Right.
There's also opportunities to make more substantial improvements,
Okay.
especially when it comes to electric motors.
The workhorses of industry.
The workhorses, that's right.
I remember seeing something in our materials about electric motors consuming the majority of industrial energy.
Yeah, they're energy hogs.
That's a lot of power.
It is. It is.
Whoa.
Which is why understanding motor efficiency and design is so crucial.
Right.
You've got some information there about NEMA motor design classifications.
Uh-huh.
It's basically a system for categorizing motors based on their torque
Okay.
and efficiency characteristics.
Right, so we've got designs A, B, C, and D.
Yeah.
But I also saw something about design E emerging as a high-efficiency option.
Yeah, that's the new kid on the block.
Is that becoming the new standard?
Well, it's definitely gaining traction.
Okay.
Design E motors can be significantly more efficient
Uh-huh.
than older models, especially for certain applications. But there are some challenges to consider.
Like what?
Well, they might have higher starting currents,
Okay.
and they aren't always readily available for every application.
Right, so it's not a simple swap.
It's not a simple swap, no.
So it's a balancing act
It's a balancing act.
between efficiency and practicality.
Exactly.
Okay.
And there's another factor that can significantly impact motor efficiency and overall system performance.
All set.
Power quality.
Power quality. I'm not sure I'm familiar with that term.
It's basically a measure of how effectively electricity is being used in a system.
Okay.
A key aspect of this is something called power factor.
Power factor, all right.
A low power factor means your system is working harder than it needs to, wasting energy
Oh.
and potentially incurring penalties from your utility company.
Penalties. That sounds expensive.
It can be. It can be.
What causes a low power factor?
A lot of things can cause a low power factor.
Okay.
Things like overloaded motors, improper wiring, or even certain types of equipment.
So it can throw things off balance.
Exactly. Makes the system less efficient.
Okay, and how do you fix that?
Luckily, there are solutions.
Okay.
The sources you provided detail some common causes
Right.
and offer some strategies for correction.
Like what?
For example, installing capacitors
Okay.
can help offset the effects of inductive loads, which are a major contributor to low power factor.
So it's not just about the equipment itself, it's
Well,
about how the whole electrical system is working together.
That's right. That's right.
Gotcha.
It's about taking a holistic view,
Yeah.
just like with those complete industrial assessments we were talking about earlier.
Right, right.
And speaking of holistic views,
Okay.
there's another crucial aspect of industrial efficiency that we need to discuss.
Okay, what's that?
Reliability. Reliability.
Reliability, okay.
Yeah, that's about keeping things running smoothly, right?
Right, avoiding those costly breakdowns and production delays.
Exactly. Reliability engineering is all about minimizing downtime
Okay.
and keeping maintenance costs under control.
So instead of waiting for something to break and then scrambling to fix it,
Yeah, that's reactive maintenance.
you're taking a more proactive approach.
Proactive, precisely.
Right.
The sources you shared outline different types of maintenance,
Uh-huh.
ranging from that reactive, fixing things only when they break,
Yeah.
to more proactive strategies
Right.
that aim to prevent those breakdowns in the first place.
And I remember seeing a great example of this in one of the case studies,
Oh, yeah?
the bakery project.
The bakery.
They were having a recurring issue with a cookie cutter breaking down.
A cookie cutter, huh?
Yeah. And it turned out it was something as simple as using the wrong type of bolts.
Wow. It's amazing how those seemingly minor details
Right.
can have such a huge impact
Yeah.
on production.
Those mismatched bolts led to frequent repairs, downtime, ultimately lost revenue.
Lost revenue, yeah.
Really highlights the importance of sweating the small stuff.
The small stuff, that's right.
Makes you wonder what seemingly insignificant maintenance oversights might be lurking in other industrial settings.
Yeah. Gives you pause, doesn't it?
Yeah, it's definitely food for thought.
Speaking of food for thought,
Yeah.
one of the most powerful tools for improving reliability
Great.
and overall system efficiency is computer simulation.
Simulation. So you're talking about creating virtual models of these systems.
Exactly. Simulation allows you to model potential changes,
Okay.
test different scenarios without any real-world consequences.
So you can experiment without breaking anything.
Exactly. It's like a virtual laboratory for industrial systems.
I like that.
Yeah,
Can you give me an example of how simulation was used in one of the case studies?
absolutely.
Okay.
Remember the bakery project we were just talking about?
With the cookie cutters?
Well, in addition to that cookie cutter issue,
Right.
they were also having some challenges with their dough mixers.
The dough mixers. Okay.
Initially, they assumed that faster mixing would mean more cookies per hour.
Yeah, that makes sense.
Seems logical, right?
Get that dough mixed quickly, move on to the next batch.
But the simulation actually revealed a bottleneck further down the line.
Oh, so even though the dough was getting mixed faster,
Yeah,
the ovens couldn't keep up.
that's right. The ovens couldn't keep up.
Oh, interesting.
Trays of unbaked cookies were piling up.
So it's like a traffic jam on a cookie assembly line.
A cookie traffic jam, exactly.
That's funny.
And this is where simulation shines.
Okay.
By slowing down the mixers.
Okay.
They actually created a more balanced workflow.
Oh, so it wasn't about making the mixers work faster.
No,
It was
no.
about making the whole system work smarter.
The whole system, that's right.
Wow.
And this principle applies to countless industrial settings.
Okay.
Simulation can help identify those hidden bottlenecks, test different scenarios,
Okay.
and optimize processes in a way that would be incredibly difficult or risky to do in the real world.
So it's like having a crystal ball that lets you see into the future of your production process.
It's a powerful tool, it is.
That's really cool.
Now let's shift gears a bit and talk about another critical aspect of industrial efficiency,
Okay.
waste reduction.
Okay, waste reduction.
What are some of the key takeaways from the materials you reviewed?
Well, one thing that struck me was the sheer variety of waste reduction strategies.
Yeah, there are a lot of different approaches.
It's not just about recycling.
No, not just recycling.
It encompasses everything from optimizing material usage to reducing water consumption
Right.
to even minimizing transportation distances.
It's all connected.
So it's a multifaceted approach.
Very multifaceted, yes.
Okay.
It's about understanding the entire life cycle of materials and products.
Okay.
And looking for opportunities to minimize waste at every stage.
Right. From beginning to end.
The Industrial Assessments.pdf document also emphasizes the importance of engaging the workforce.
Oh, that's interesting.
Yeah.
So you're not just talking about like top-down initiative.
No, you need buy-in from everyone.
You need buy-in from everyone.
Absolutely. Frontline workers often have the most intimate knowledge
Right.
of the process.
They're the ones who are actually doing the work.
Exactly. They can offer invaluable insights into where waste is occurring
Right.
and how to reduce it.
So how do you get them involved?
Well, the document suggests a few things,
Okay.
like implementing suggestion boxes.
Okay, so they can share their ideas.
Yeah, conducting training sessions,
Uh-huh.
even offering incentives for waste reduction ideas.
Oh, that's a good idea.
It's about empowering the people who are closest to the action.
Right, the ones who are actually seeing the waste happening.
That's right.
Have you seen examples of this working well in practice?
Well, absolutely.
Like what?
Sometimes the simplest solutions are the most effective.
Yeah.
I like those.
For instance, the document highlights a case study where a factory significantly reduced their packaging waste
Yeah.
simply by switching to a different box size.
A different box size. That's brilliant.
Simple but effective.
No fancy technology, just a little bit of creative thinking.
Exactly, and that's the essence of waste reduction.
Okay.
It's about challenging assumptions, seeking out opportunities for improvement,
Right.
and remembering that every little bit counts.
Every little bit counts.
Just like with those energy-saving tips we discussed earlier,
Right.
small changes can have a significant cumulative impact.
It's a reminder that we can all play a part in making industrial systems more sustainable.
Absolutely.
Okay, so now I'd love to circle back to those case studies from the dissertation.
Okay, the case studies.
We've talked about the confectionery company and the bakery.
Yeah?
But I'm curious to hear more about the power plant
The power plant.
and the grain miller.
Okay.
Those seem like very different environments. They are quite different.
Okay.
The power plant case study focused on the challenges of working with an aging facility.
Right, because power plants have a lot of, big equipment.
Big old equipment.
Yeah.
A major part of the assessment involved evaluating whether to replace older motors with newer, more efficient models,
Okay.
or to rewind the existing motors.
That's a tough decision.
It is a tough decision.
Replacing motors is a big upfront investment.
A big investment, yeah.
But rewinding might not give you the same level of efficiency improvement.
That's right.
So it's a balancing act.
It's a balancing act.
And each situation is unique.
Every situation is different.
So there's no easy answer.
No easy answers.
The assessment team had to carefully consider all sorts of factors.
Yeah, they had to look at the remaining lifespan of the existing motors,
Okay.
the availability of replacement parts,
Right.
and the potential energy savings from each option.
Right. So it's not a one-size-fits-all solution.
Definitely not.
Okay.
Now, the grain miller case study was interesting
Okay, why is that?
because it involved a multi-phase assessment.
Multi-phase. Okay.
The first phase involved a broad overview of the entire facility.
So they were casting a wide net initially.
A wide net, exactly.
Okay.
Identifying potential areas for improvement
Right.
across a whole range of processes.
Okay, so they weren't focusing on anything specific at first.
Not at first, not
Just trying to get a big picture view.
the big picture, that's right.
Then in the second phase,
Yeah,
they narrowed their focus
they narrow it down.
to a few key areas, conducting more detailed audit
Detailed audits, yeah.
of things like the compressed air system,
Okay.
the steam system,
Uh-huh.
even the pump seals.
Bump seals, interesting.
Pump seals, that sounds pretty specific.
It might seem mundane, but leaky pump seals were actually a major source of waste at this grain miller.
Wow, really?
They were losing valuable product,
Oh,
wasting energy,
okay.
and even creating safety hazards.
Wow, so those little things can have big consequences.
Big consequences, that's right.
What did they find during those targeted audits?
Well, the compressed air system was another area ripe for improvement.
Okay, what was going on there?
They discovered a number of leaks,
Leaks, okay.
which were wasting energy
Uh,
and reducing the system's efficiency.
so just like with the confectionery company,
Yeah.
those seemingly small leaks were adding up to significant losses.
Little leaks, big consequences.
That seems to be a recurring theme here.
It is a recurring theme, yeah.
Interesting.
They recommended a comprehensive leak detection and repair program,
Okay.
which would not only save energy,
Yeah.
but also extend the life of the compressor equipment.
Okay, that makes sense.
They also found ways to optimize the system pressure
Okay.
and even adjust the control settings to further improve efficiency.
So they were really fine-tuning that system
Fine-tuning, yeah.
to squeeze out every bit of performance.
Yeah, every bit of performance, that's right.
It's impressive.
And they took a similar approach with the steam system,
The steam system, okay?
identifying leaks,
Okay.
optimizing trap performance,
Mm-hmm.
even exploring ways to capture and reuse waste steam.
Wow, so they were really looking at every possible angle.
It's all about taking that holistic view
Yeah.
and looking for opportunities to improve every aspect of the operation.
It's like they were putting the entire facility under a microscope
A microscope, yeah.
to identify every potential area for improvement.
Every little detail.
That's amazing.
And that's a key takeaway from all these case studies.
Okay.
Whether we're talking about energy audits,
Yeah.
waste reduction,
Right.
or reliability engineering.
Yeah.
It's all about taking a step back and considering the
Interconnectedness.
of all these elements.
It's not just about looking at one thing in isolation.
No, it's about systems thinking,
Systems thinking, not siloed thinking.
not siloed thinking. That's right.
It's like we're exploring this uncharted territory.
Yeah.
Mapping out the complex world of industrial systems.
It's a complex world.
Yeah. And uncovering all sorts of hidden treasures.
Hidden treasures. I like that.
That's fascinating stuff.
It is fascinating. The sources you provided give us a great foundation for this exploration.
Yeah, it's a great starting point. Yeah, it really is fascinating to see how much potential there is for improvement when you start looking at these industrial systems from this holistic perspective.
It is. It's like peeling back the layers of an onion, you know?
Right.
There's always something more to discover, another opportunity to optimize, another layer of efficiency to unlock.
And you know, as we've been discussing all these technical details,
Yeah.
I keep coming back to something that struck me in that dissertation.
Oh, yeah.
The importance of the human element.
The human element, right?
It's not just about the machines and the processes.
Yeah.
It's about the people who design, operate, and maintain those systems.
Absolutely. You can have the most cutting-edge technology in the world,
Right.
but it's only as good as the people who are using it.
The dissertation actually talks about the need to create a culture of continuous improvement,
A culture of continuous improvement.
where everyone feels empowered to contribute.
Exactly. It's about fostering an environment where suggestions are welcomed.
Right.
Ideas are explored, innovation is celebrated.
It's amazing what can happen when you tap into that collective knowledge and creativity
It really is.
of the entire workforce.
The whole team.
It makes sense.
Yeah.
The people who are closest to the action, the ones who are working with these systems day in and day out,
They're the ones who really know.
they often have the best insights into where improvements can be made.
Absolutely. And it's not just about finding those quick fixes either.
Right.
It's about empowering people to think critically about the processes they're involved in.
Okay.
Question assumptions. Come up with creative solutions to problems.
It sounds like that kind of cultural shift can lead to some pretty impressive results.
It can. It really can.
And it goes beyond just improving efficiency and productivity.
That's right.
When you create a workplace where people feel valued and empowered,
Right.
it can also lead to increased job satisfaction,
Absolutely.
improved morale,
Happier employees.
even reduced turnover.
It's a win-win all around.
It really is.
And I think that's a great takeaway from our deep dive today.
Okay, what's that?
It's not just about the technical aspects of industrial systems. It's about the people, the culture, and the constant pursuit of improvement.
Well said. So as we wrap up this deep dive,
Okay.
what are some key takeaways that you hope our listener will walk away with today?
Well, I think the biggest takeaway is the importance of taking a holistic approach.
Holistic approach, okay.
Whether you're conducting an energy audit, looking for ways to reduce waste,
Right.
or trying to improve reliability.
Yeah.
It's essential to consider the interconnectedness of all these elements.
The interconnectedness.
Don't get stuck in silos. Think about the system as a whole.
Think about the whole system.
Also,
And don't underestimate the power of small changes.
just small changes. Yeah.
Sometimes those seemingly insignificant tweaks can add up to significant improvements over time.
Absolutely. Every little bit helps.
And remember, it's an ongoing journey.
Journey, yeah.
There's always more to learn, more to improve, and more to discover.
That's a great point.
This deep dive has been incredibly insightful.
It has been.
And I hope it's sparked some new ideas and inspired our listener to take a fresh look at the systems they're interacting with.
I hope so too. It's been a pleasure diving into these materials with you.
Thanks for joining us on this deep dive into the world of industrial systems.
It's been fun.
We hope you've enjoyed the journey and come away with some valuable insights to apply in your own pursuits.
Until next time.
Keep those mental gears turning.
Keep learning. Welcome, everyone. Ready to do a deep dive with me into the economics of machinery maintenance in manufacturing?
Sounds fascinating.
I know, right? We've got some really great research papers and reports from the National Institute of Standards and Technology.
NIST.
NIST, yeah, to help us really unpack all of this.
I love NIST.
They're great, I know.
Oh.
Get ready for some really big numbers.
Oh, yeah.
And some surprising insights.
Buckle up.
Yeah, buckle up.
You are going to be shocked by how much money is tied up in keeping machines running smoothly.
I bet.
A 2016 NIST study found that maintenance costs plus the losses that could have been prevented actually totaled a staggering
Go on.
$193.6 billion.
Billion. Wow.
In U.S. manufacturing.
Wow. That is huge. I mean, that figure is bigger than the entire GDP of many countries.
It is.
It's pretty easy to see how overlooking maintenance could have, like, a major ripple effect on a company's bottom line, right?
Absolutely. And it's not just about the direct costs of fixing things.
Right.
We need to consider those knock-on effects like unplanned downtime and product defects, which can ultimately lead to lost sales.
Like you were saying, $193.6 billion.
Yeah.
The study breaks down these costs, right? Like, what's the real culprit here?
Yeah. So it turns out that almost half of those costs
Really?
are directly attributed to lost sales.
Wow.
It's a massive hidden cost that many manufacturers might not even realize they're dealing with.
It's almost like you're losing money by not spending money on this.
Yeah, you got to spend money to make money.
So neglecting maintenance isn't just about repair costs. It's a direct hit to your profitability.
100%.
This really highlights how strategic maintenance planning needs to be.
100%. Yeah. Every minute a machine is down for unplanned maintenance translates to potential products you could have sold but can't.
Yeah.
Plus, consistent delays can really damage a company's reputation with customers.
Yeah, that makes total sense.
No.
Okay, so let's talk about the different approaches that companies can take to kind of keep their machines in tip-top shape.
Well,
The NIST research outlines 3 main strategies:
okay.
reactive maintenance, or RM,
Mhm.
preventive maintenance, or PM,
Okay.
and predictive maintenance, which is PDM.
It's like choosing your character class in a manufacturing RPG.
I was going to say it's like a video game or something, right?
Yes.
Each approach has its own strengths and weaknesses.
Totally.
I love that analogy. Okay, so RM is like your classic, if it ain't broke, don't fix it mentality.
Right.
It might seem appealing at first.
It's tempting.
It is tempting, but what are the downsides?
Well, as we've kind of seen, RM often leads to those massive costs down the line, and it can potentially compromise safety.
Got it.
It's a reactive firefighting approach that can leave you scrambling when things go wrong.
For sure. And then there's PM, which is more about scheduled tune-ups based on time or usage.
Right.
It's about trying to prevent those unexpected breakdowns before they actually happen.
Exactly. It's a more proactive approach that can help minimize downtime and keep things running smoothly.
Okay, and then finally we have PDM, which sounds like the most high-tech approach.
Oh, yeah.
What's the key idea behind PDM?
PDM leverages data and sensors to anticipate when a machine might need attention.
Interesting.
It's all about optimizing resources and staying ahead of potential issues, potentially saving significant amounts of money in the process.
So it's almost like having a crystal ball
It is like a crystal ball.
for your machinery.
For sure.
That sounds incredibly efficient, but I imagine implementing PDM requires a significant investment right here.
It does. But the research that we're looking at strongly suggests that the potential benefits can outweigh those upfront costs.
For sure. It's interesting that even something as simple as a light bulb
I know, right?
can be analyzed through this lens of these maintenance strategies.
Yeah.
I was reading that in this specific case, the NIST researchers actually advocate for RM,
Yes.
which seems a bit counterintuitive.
I know it does, but they make a really compelling case for why a broken light bulb doesn't warrant a more complex approach like PM or PDM. Think about it. A burnt-out bulb very rarely causes like a chain reaction of failures.
True.
They're readily available and inexpensive.
Yeah,
And replacing one is super easy.
it's very easy. Yeah, I've done it many times.
Exactly.
That's a good point. It highlights how the best maintenance strategy isn't always the most complex one,
Right.
but rather the one that's most appropriate for the specific situation.
100%.
It depends.
Yeah.
Okay, so now let's get back to those more advanced strategies and dig into some of the potential benefits of PDM.
Let's do it.
What makes this approach so attractive to manufacturers?
Well, the research highlights some really compelling advantages.
Okay.
For instance, one study found that manufacturers who were heavily reliant on RM experienced a
Wait.
whopping 3.3 times more downtime
Wow,
than those who incorporated other approaches.
Oh, that's a huge difference.
Huge.
It really drives home the point that unplanned downtime can be a major drain on resources.
Oh, yeah, for sure.
And I can only imagine the frustration it causes for customers who are waiting on those orders.
It's a nightmare.
You're absolutely right, but the downsides don't even end there.
No, they don't.
The same study found that those heavily reliant on RM also experience 16 times
16 times.
more defects.
More defects.
So not only are they dealing with production delays, but the products that they do manage to make are more likely to have issues.
It's a double whammy.
It sounds like PDM is the clear winner here, right?
It does, doesn't it?
Fewer delays, higher quality products, what's not to love?
I love it.
But I'm curious, how widely adopted is PDM in the real world? Are most manufacturers already on board with this approach?
That's a great question.
Yeah.
So the NIST data from 2016 gives us a snapshot of what U.S. manufacturing looked like back then.
Okay.
On average, only 17.3% of maintenance activities
Oh, wow.
were classified as PDM.
Okay.
Preventive maintenance accounted for 31.8%.
Good.
And a surprising 45.7% were still heavily reliant on RM.
Wow, that's a lot of companies potentially missing out on the benefits of PDM.
Yeah.
Why do you think so many manufacturers are still stuck in that reactive mode? What are the barriers to change?
That's a complex question with a few potential answers.
Sure.
Shifting to a more proactive approach like PDM requires an investment in technology training and a change in mindset.
Uh-huh.
Some companies may be hesitant to make that initial investment, even if it promises those long-term savings.
Yeah, I can understand the change can be daunting, especially for larger companies with like established processes.
It is, yeah.
But it seems like the potential benefits of PDM far outweigh the challenges then.
I think so.
Did the NIST research find any connection between a company's investment in maintenance and the overall results that they actually achieve?
They did.
Really?
The survey data suggests that companies that invest more in their maintenance operations
Okay.
tend to utilize PDM more frequently.
Interesting.
And not surprisingly, they also report less downtime, lower defect rates, and fewer lost sales.
It paints a pretty clear picture, doesn't it?
It does.
Investing in maintenance, particularly PDM, seems to be like a smart move
Yeah,
for manufacturers aiming to improve efficiency and profitability.
seems like it. Yeah.
Now, it's interesting.
Yeah.
Did the research look into how these strategies play out in companies with different production models?
They did.
Interesting.
Like those who produce goods in anticipation of demand versus those who make things to order.
Right, like custom.
Yeah. Yeah.
Okay, so they did look into that.
They did.
What did they find?
Okay, so they specifically looked at push and pull production strategies.
Okay.
So to recap, push is also known as make to stock.
Okay.
And that involves producing goods based on anticipated demand and keeping inventory on hand.
Got it.
So think of a clothing company manufacturing thousands of shirts in various sizes before knowing exactly who will buy them.
I got it. So pull or make to order
Yeah.
would be more like a company that builds custom furniture based on specific customer requests.
Exactly. And what the researchers discovered is fascinating.
Okay. Alrighty.
Companies primarily employing a pull strategy
Okay.
reported a higher percentage of their downtime being related to maintenance.
Interesting. That seems counterintuitive.
It does.
Why would companies making things to order be more susceptible to maintenance-related downtime?
It surprised me too at first.
Yeah.
But it makes sense when you consider that in a make-to-order environment, every delay directly impacts the company's ability to meet customer deadlines.
For sure.
Even a single machine malfunctioning
Yeah.
could throw off that entire production schedule.
Yeah. I see what you mean. Those delays probably stand out even more to customers who are eagerly awaiting their custom-made product.
For sure.
They want that special thing.
Exactly. So in these make-to-order scenarios, having a robust maintenance strategy is absolutely critical.
Yeah.
They need to be extra vigilant about PM and seriously consider investing in PDM to minimize those disruptive breakdowns.
Yeah. So it's interesting how the choice of production model can have such a significant impact on the importance of maintenance.
Absolutely.
It's another reminder that maintenance isn't just a technical consideration.
Right.
It's deeply interwoven with a company's overall strategy.
100%.
Absolutely.
Yeah.
And speaking of strategy,
Yeah.
the research also delved into how different management styles can influence a company's approach to maintenance.
I love this part.
It sounds intriguing. Tell me more about that connection.
Okay, so they asked the survey respondents to categorize their primary management style, offering 4 options.
Okay.
Autocratic, consultative, democratic, and delegative.
Got it.
As a reminder, autocratic means decisions are made solely at the top,
Yep.
while the other styles incorporate varying levels of employee input.
Right. So they wanted to see if there was a correlation between the type of management style and the maintenance approach.
Exactly.
And what did they find?
They found a correlation between a delegative management style, where employees have significant autonomy in decision-making,
Right.
and a higher percentage of RM being used.
Wow. That's surprising. I would have assumed that giving employees more control over their work would lead to more proactive maintenance practices.
You would think so, right?
Not less so. Why do you think that is?
It does seem counterintuitive on the surface.
Yeah.
One possible explanation is that in these delegative environments, there might not be enough oversight or guidance
Right.
when it comes to maintenance tasks.
It's just not a priority.
It might get lost in the shuffle.
Do you think it's possible that in these situations, employees might be prioritizing other tasks and pushing maintenance to the back burner until a problem forces their hand?
I think that's very possible.
Yeah.
It really highlights the importance of clear communication and leadership, even in workplaces that value employee empowerment.
So it's a delicate balancing act,
It is.
empowering employees
Yes,
while ensuring that critical tasks like maintenance don't get neglected.
100%.
And this brings us back to our discussion about transitioning to PDM.
Yes.
Are you ready to explore the steps involved in making that shift?
Let's do it.
Okay, so let's dive into those practical steps.
Let's go.
What does this transition to PDM actually look like? Where do companies even begin?
The NIST researchers outlined several key areas to focus on.
Yep.
First, you need to figure out what data is crucial for predicting potential failures.
Oh,
This could include things like temperature readings, vibration patterns, pressure levels, or even the sounds that a machine makes.
it's those old school mechanics who could pinpoint an engine problem just by listening to it.
Exactly, except now we're not solely relying on human senses.
Right.
We can use sensors to gather that data continuously
Right.
and with much more objectivity.
That makes sense. So you've outfitted your machines with sensors.
Yep.
You're collecting all this data.
Yep.
Now what? How do you actually make sense of it all?
That's where data analysis and modeling come in. So you need to establish baseline readings for each machine when it's operating normally.
Okay.
Then you look for any deviations that might signal a developing issue.
So it's like creating a digital fingerprint for each machine
I love that analogy.
and then constantly monitoring for any anomalies.
Exactly.
Okay. I like that now, thankfully, there are sophisticated software tools available
Oh, yeah.
that can help with this analysis.
For sure.
These programs use machine learning algorithms to detect subtle patterns that humans might miss.
Yes, they're very powerful tools.
That's incredible.
Mhm.
So now you've identified those key data points. You're analyzing it. You're able to flag those potential problems.
Yep.
What happens next? Do you immediately dispatch a technician to fix everything the computer highlights?
Not necessarily. It's about setting clear thresholds
Got it.
and developing a tailored maintenance plan based on the severity and urgency of that predicted failure.
Okay.
So, for example, a small temperature increase might only require closer monitoring,
Uh.
whereas a sudden spike in vibration could necessitate immediate action.
So PDM isn't about overreacting to every little blip.
Exactly.
It's about using data to prioritize and optimize your maintenance efforts.
Yes, and this is where human expertise is still indispensable.
I was going to say, we're not getting rid of the humans.
No,
It's just helping them.
it's giving them the right information.
Right.
While the data can reveal a lot, you still need skilled technicians who understand the intricacies of the machines and can interpret the data within the context of the overall operation.
It's a perfect example of humans and technology actually working together.
I agree.
We're not replacing humans with machines. We're equipping them with better tools and information to make more informed decisions.
100%.
Now, this also brings up the importance of training.
Yes.
As companies adopt PDM,
Uh-huh.
they need to invest in upskilling their workforce, right?
Right.
They need to equip their employees with the knowledge and skills
Yes.
to use these new technologies effectively and interpret the data accurately.
It's all about training.
And I imagine there's a cultural shift involved as well.
Oh, for sure.
If a company is used to reacting to problems,
Yeah.
it might take some time to adapt to this more proactive, data-driven approach.
It's a gradual process, not a sudden overnight switch.
For sure.
It requires changing mindsets as much as it does changing processes.
I'd love to hear an example of this in action.
Oh, yeah.
Do you know of any companies that have successfully implemented PDM and seen like positive results?
Oh, there are countless examples.
I bet.
I recently read about a large beverage company
Okay.
that was struggling with frequent breakdowns on their bottling line.
Okay.
They decided to invest in PDM technology, and they saw a dramatic reduction in downtime,
Wow.
which led to a significant increase in production output and a boost to their bottom line.
That's a fantastic illustration of how powerful this shift to PDM can actually be.
It really is.
It's encouraging to hear these real-world success stories.
It is inspiring to see how companies are leveraging this technology to improve their operations and create a more stable and productive work environment.
Absolutely. This deep dive has been incredibly enlightening.
I've had fun.
We've covered so much ground, from understanding the economic impact of maintenance to exploring various strategies and even diving into the practical steps involved in adopting PDM.
It's been a journey.
I hope our conversation has inspired you to rethink your own approach to maintenance.
Me too.
But before we wrap up,
Okay.
I have one final thought I want to leave with our listeners.
I'm listening.
We've focused a lot on the potential cost savings
Mm-hmm.
and the efficiency gains from PDM.
Right.
But what about the human impact?
That's such an important point. We often get caught up in the numbers,
Yeah.
but there's a human element to the story that deserves attention.
Exactly. If PDM can help companies avoid those stressful last-minute repairs
Yeah.
and reduce that unplanned downtime,
Mm-hmm.
it could actually lead to a calmer
Totally.
and more predictable work environment.
100%.
And that can translate into higher employee morale, reduced stress levels, and potentially even fewer workplace injuries.
It's a win-win.
So as you evaluate and refine your maintenance strategies, remember to consider the people involved.
The people.
A well-maintained workplace is a happier and safer workplace
It is.
for everyone.
Well said. I couldn't agree more.
And on that note, we'll wrap up this deep dive into the world of manufacturing maintenance.
Awesome.
Thanks for joining us.
It's been a pleasure. The research highlights some really compelling advantages.
Okay.
For instance, one study found that manufacturers who were heavily reliant on RM experienced a whopping 3.3
Wow,
times more downtime
that's a lot.
than those who incorporated other approaches.
Ouch. That is a significant difference.
It is.
It really drives home the point that unplanned downtime can be like a major drain on resources.
Really?
And I can only imagine the frustration it causes, like we said before, for those customers that are waiting on orders. You're right, but the downsides don't even end there.
No, they don't.
The same study also found that those heavily reliant on RM also experienced 16
times
more defects.
more defects.
So not only are they dealing with production delays, but the products that they do manage to make are more likely to have issues.
It's a double whammy.
It seems like PDM is the clear winner here, right?
It seems that way.
Fewer delays, higher quality products. I
Yeah.
mean, what's not to love?
Right.
I'm curious, how widely adopted is PDM in the real world? Like, are most manufacturers already on board with this approach?
That's a great question. And the NIST data from 2016 provides a snapshot of what U.S. manufacturing looked like back then.
Right?
On average, only 17.3%
Oh, wow, so small.
of maintenance activities were classified as PDM.
Okay.
Preventive maintenance accounted for 31.8%.
Okay.
And a surprising 45.7% were still heavily reliant on RM.
Wow, that's a lot of companies potentially missing out on the benefits of PDM.
Yeah.
Why do you think so many manufacturers are still stuck in that reactive mode? Like, what are the barriers to change?
That's a complex question.
Sure.
With a few potential answers.
Of course.
Shifting to a more proactive approach, like PDM, requires an investment in technology training and a change in mindset.
Yeah.
Some companies may be hesitant to make that initial investment, even if it promises those long-term savings.
I can understand that change can be daunting, especially for larger companies with those established processes.
It's hard to change.
It is, but it seems like the potential benefits of PDM far outweigh the challenges, right?
I think so.
Did the NIST research find any connection between a company's investment in maintenance and the overall results they actually achieve?
They did. The survey data suggests that companies that invest more in their maintenance operations tend to utilize PDM more frequently.
Makes sense.
And not surprisingly, they also report less downtime, lower defect rates, and fewer lost sales.
It paints a pretty clear picture.
It does.
Investing in maintenance, particularly PDM, appears to be a smart move
I think so.
for manufacturers that are aiming to improve efficiency and profitability.
It seems like it.
Okay, so we've discussed the different strategies
Yes.
and how they relate to a company's goals.
Right.
But I'm curious, did the research explore how these strategies play out in companies with different production models?
They did.
Interesting.
Like those who produce goods in anticipation of demand versus those who make things to order.
Right, like custom.
Yeah,
So they did look into that.
they did.
What did they find?
Okay, so they specifically looked at push and pull production strategies.
Okay.
To recap, push, also known as make to stock, involves producing goods based on anticipated demand and keeping that inventory on hand.
Got it.
So think of a clothing company manufacturing thousands of shirts in various sizes before knowing exactly who will buy them.
Got it. So pull or make to order would be more like a company that builds custom furniture based on specific customer requests.
Exactly.
Okay.
And what the researchers discovered is fascinating.
I'm ready.
Companies primarily employing a pull strategy reported a higher percentage of their downtime being related to maintenance.
Interesting. That seems counterintuitive.
I know, right?
Why would companies making things to order be more susceptible to maintenance-related downtime?
It surprised me too at first.
Yeah.
But it makes sense when you consider that in a make-to-order environment, every delay directly impacts the company's ability to meet those customer deadlines.
Absolutely.
Even a single machine malfunctioning could throw off that entire production schedule.
For sure. I see what you mean. Those delays probably stand out even more to customers who are eagerly awaiting their custom-made product, right?
Absolutely. They want that special thing.
Yeah.
So in these make-to-order scenarios, having a robust maintenance strategy is absolutely critical.
Makes sense.
They need to be extra vigilant about PM and seriously consider investing in PDM to minimize those disruptive breakdowns.
So it's interesting how the choice of production model can have such a significant impact on the importance of maintenance.
It is.
It's another reminder that maintenance isn't just a technical consideration, it's deeply interwoven with the company's overall strategy.
100%.
Absolutely. And speaking of strategy,
Yeah.
the research also delved into how different management styles can influence a company's approach to maintenance.
I love this part.
Now that sounds intriguing. Tell me more about that connection.
Okay, so they asked the survey respondents to categorize their primary management style, offering 4 options.
Okay.
Autocratic, consultative, democratic, and delegative.
Okay.
As a reminder, autocratic means decisions are made solely at the top,
Yes.
while the other styles incorporate varying levels of employee input.
Right. So they wanted to see if there was like a correlation between the management style and
Exactly.
the maintenance approach.
Exactly.
Okay. So what did they find?
They found a correlation between a delegative management style where employees have significant autonomy in decision-making and a higher percentage of RM being used.
That's surprising. I would have assumed that giving employees more control over their work would lead to more proactive maintenance practices.
You would think so, right?
Not less so. Why do you think that is?
It does seem counterintuitive on the surface. One possible explanation is that in these delegative environments, there might not be enough oversight or guidance when it comes to those maintenance tasks.
Right. It just doesn't become a priority.
Yeah, it gets lost in the shuffle.
Do you think it's possible that in these situations, employees might be prioritizing other tasks and pushing maintenance to the back burner until a problem forces their hand?
I think that's very possible. Yeah, it highlights the importance of clear communication and leadership, even in workplaces that value employee empowerment.
So it's a delicate balancing act,
It is.
empowering employees while ensuring that those critical tasks like maintenance don't get neglected.
100%.
And this brings us back to our discussion about transitioning to PDM.
It does.
Are you ready to explore the steps involved in making that shift?
Yes, let's do it. Yeah, let's dive into those practical steps.
Okay, so what does this transition to PDM actually look like?
Yeah.
Where do companies even begin?
Well, the NIST researchers outlined several key areas to focus on. First, you need to figure out what data is crucial for predicting potential failures. This could include things like temperature readings, vibration patterns, pressure levels, or even the sounds a machine makes.
It's like those old school mechanics,
Yeah.
who can pinpoint an engine problem just by listening to it.
Exactly, except now we're not solely relying on human senses. We can use sensors to gather that data continuously and with much more objectivity.
Okay, so you've outfitted your machines with sensors, and you're collecting all of this data. Now what? How do you actually make sense of it all?
That's where the data analysis and modeling come in. So you need to establish those baseline readings for each machine when it's operating normally. Then you can look for any deviations that might signal a developing issue.
So it's like creating a digital fingerprint
I love that.
for each machine and then constantly monitoring for any anomalies.
That's a great analogy, and thankfully there are sophisticated software tools available now that can help with this analysis. These programs use machine learning algorithms to detect those subtle patterns that humans might miss.
That's incredible. So now you've identified the key data points, you're analyzing it, you're able to flag potential problems. What happens next? Do you immediately dispatch a technician to fix everything the computer highlights?
Not necessarily. It's about setting clear thresholds and developing a tailored maintenance plan based on the severity and urgency of that predicted failure. For example, a small temperature increase might only require closer monitoring, while a sudden spike in vibration could necessitate immediate action.
So PDM isn't about overreacting to every little blip. It's about using data to prioritize and optimize your maintenance efforts.
Precisely, and this is where human expertise is still indispensable.
I was going to say, right, we're not replacing those humans with machines. We're just giving them better tools,
Exactly.
information.
While data can reveal a lot, you still need skilled technicians who understand the intricacies of the machines and can interpret the data within the context of the overall operation.
So it's really humans and technology working together.
I agree.
We're not replacing humans with machines. We're equipping them with better tools and information to make more informed decisions.
100%. This also brings up the importance of training. As companies adopt PDM, they need to invest in upskilling their workforce. They need to equip their employees with the knowledge and skills to use these new technologies effectively and interpret that data accurately.
And I imagine there's a cultural shift involved as well, right? If a company's used to reacting to problems, it might take some time to adapt to this more proactive, data-driven approach.
Absolutely. It's a gradual process, not a sudden overnight switch. It requires changing mindsets as much as it does changing processes.
For sure. I'd love to hear an example of this in action. Do you know of any companies that have successfully implemented PDM and seen positive results?
There are countless examples. I recently read about a large beverage company that was struggling with frequent breakdowns on their bottling line. They decided to invest in PDM technology and saw a dramatic reduction in downtime, which led to a significant increase in their production output and a boost to their bottom line.
That's a fantastic illustration of how powerful this shift to PDM can be.
Yeah.
It's encouraging to hear those real-world success stories.
It is inspiring to see how companies are leveraging this technology to improve their operations and create a more stable and productive work environment.
This deep dive has been incredibly enlightening. We've covered so much ground, from understanding the economic impact of maintenance to exploring the various strategies and even diving into the practical steps involved in adopting PDM.
It's been a lot of fun. I agree.
I hope our conversation has inspired you to rethink your own approach to maintenance.
Me too.
But before we wrap up, I have one final thought that I want to leave with our listeners. We've focused a lot on the potential cost savings and efficiency gains from PDM, but what about the human impact?
That's such an important point. We often get so caught up in the numbers, but there's a human element to this story that deserves attention.
Exactly. If PDM can help companies avoid those stressful last-minute repairs and reduce unplanned downtime, it could lead to a calmer and more predictable work environment for everyone.
Absolutely. That can translate into higher employee morale, reduced stress levels, and potentially even fewer workplace injuries.
So as you evaluate and refine your maintenance strategies, remember to consider the people involved. A well-maintained workplace is a happier and safer workplace for everyone.
Well said. I couldn't agree more.
And on that note, we'll wrap up this deep dive into the world of manufacturing maintenance. Thanks for joining us.
It's been a pleasure. All right, so welcome to another deep dive, and today we're diving into a company called MotorDoc LLC.
Oh, interesting.
Yeah, they're doing some really, really cool things with motor and generator health.
Okay.
And what's really caught my eye is, well, they have their website and product pages like all companies do, but the founder actually has a YouTube vlog.
Wow.
And it's super techy, which, you know, I'm all about.
Yeah, you don't see that every day, that level of kind of insider perspective.
Exactly. Yeah.
And one of the things that really makes MotorDoc stand out to me is their use of what's called electrical signature analysis.
Okay.
ESA.
ESA.
And this is, think of it as a way to kind of hear the heartbeat of your entire motor system.
Okay.
Not just like isolated points.
So instead of checking your pulse at your wrist, you're listening to the whole cardiovascular system.
Exactly.
Okay.
You got it. So traditional methods, things like accelerometers, those are like that single point, right?
Yeah.
You're just getting the pulse of the wrist.
Right.
ESA is giving you a much more holistic view of what's going on in the entire system.
Gotcha.
And so it's about analyzing the whole electrical system, and by doing that, you can spot problems that might otherwise, completely slip through the cracks.
That makes sense.
Yeah.
So I'm already kind of intrigued by this, but on their website they talk about the empath family,
Right.
and it seems like it's like a whole group of systems and tools for motor monitoring.
Yeah.
So where do these systems fit into the big picture?
So they've got systems for everything. They've got continuous monitoring systems for constant vigilance.
Right.
They call that Empath CMS.
Okay.
They have portable diagnostic tools,
Mm-hmm.
like the Empath Portable, and that's really designed for on-the-spot troubleshooting.
Okay.
And what's, I think, even more fascinating is that this technology actually has roots in Oak Ridge National Labs.
Oh, wow.
It was originally developed for nuclear applications.
So nuclear grade tech for my wind turbine.
Right, yeah,
That's quite a pedigree.
it is.
But how did they make that leap from, nuclear to something a little more practical?
Well, they managed to take that really robust, reliable core technology and adapt it for industrial use.
Okay.
And that's a big part of what we see in their Empower software.
Okay.
And this is where that YouTube vlog really gets interesting.
Okay. So the vlog, it's a deep dive into Empower.
Yeah.
What kind of insights are we getting into?
So it gets pretty technical.
Okay.
But the founder walks us through some really cool features.
Okay.
Like, for example, Empower can actually analyze superharmonics, those super high frequency electrical signals, in a range from 2 kilohertz to 22 kilohertz.
Wow.
And they're planning on expanding that all the way up to 150 kilohertz.
Okay.
It's meeting the 61000 D340 standard. But the real takeaway here is this broad frequency range allows them to pick up on these very subtle issues that other systems they miss.
Okay.
Yeah.
So like they're listening with a super powered stethoscope.
That's a great way to put it.
What kind of issues are we talking about though? And why should I care about those super high frequencies?
So think of superharmonics, like these tiny whispers that reveal hidden stresses within the motor.
Oh, okay.
Okay. And by analyzing those whispers, MotorDoc can actually detect things like bearing wear, insulation breakdown,
Oh, wow.
even problems in connected components like gearboxes, and even, believe it or not, the blades.
Wow.
And they can do this long before those things become major failures.
Okay.
And for you, that means less downtime, lower repair costs, and a safer overall operation.
That's impressive. And I noticed they have this huge database of bearing information built right into the software.
Right.
Over 83,000 entries, it said.
It's amazing.
So what's the purpose of that?
It's like a fingerprint library for bearings.
Okay.
So when Empower analyzes a motor, it compares the signals to this massive database, and it helps them to pinpoint, specific bearing types and really identify any potential issues very specifically. It's a level of detail you just wouldn't get with traditional methods.
So they're serious about data.
Yeah.
I can see that.
Yeah.
And from what I saw in the vlog, they're not just like analyzing the data. They're using it to develop some really, really specialized features, especially for wind turbines.
Absolutely.
What caught your eye there?
Well, I think what's really interesting is their focus on making continuous monitoring a reality for wind turbines.
Right.
It's a big challenge.
Yeah.
Because of just the logistics of getting up to the nacelle all the time. But they're already doing periodic testing.
Okay.
So they're gathering data at set intervals, even in those hard-to-reach places.
So less climbing towers and more data-driven insights.
Exactly.
I like that.
Yeah.
What else are they doing that's, specifically for wind turbines?
Well, they've analyzed data from over 6,000 wind turbines.
Wow.
Which has allowed them to develop specific algorithms and rules that are tailored to those applications.
Gotcha.
In fact, their gearbox playbook is actually included in the guidelines for American Clean Power. So that's a big deal in the wind industry.
Oh, wow. Okay. So they're not just like adapting their tech. They're going deep on wind turbine specific issues.
Yeah.
And speaking of deep dives, the founder mentions something called planetary gear set analysis that they're adding to Empower.
Right.
What is that and why is it important for wind?
So planetary gear sets are a specific type of gear system that's very commonly used in wind turbines. And that's because they're compact and they're very efficient at handling those high torque loads. Imagine a set of gears that are arranged like a miniature solar system with a sun gear in the center and planet gears orbiting around it.
Okay.
They're very complex systems.
Yeah.
And being able to analyze them specifically is a major advantage for wind turbine operators.
So it's like they're giving you X-ray vision into the heart of your wind turbine.
It is.
That's wild.
And this all ties into, they used to have a simple AF's scoring system.
Okay.
But they're switching to something called severity levels.
Okay, what does that mean for someone using the software?
Well, instead of just seeing, a letter grade,
Right.
you're going to get a much clearer understanding of how urgent a problem is.
Okay.
This means you can prioritize repairs,
Right.
allocate resources effectively,
Yeah.
and avoid those really costly downtime events
Mm-hmm.
by addressing the most critical issues first.
Gotcha. So it's not just about knowing there's a problem. It's
Yeah.
about understanding the full context.
Exactly.
Yeah.
You got it.
Now, all this is impressive, but what really, really caught my eye was MotorDocAI.
Yes.
It seems like they're taking this whole data thing to a whole new level.
They are. That's where things get really interesting, because MotorDocAI is all about harnessing the power of artificial intelligence and data science
Yeah.
to go beyond just diagnosing problems.
Mm-hmm.
They're actually looking to predict and prevent failures before they even happen.
Hold on, predict the future.
Yeah.
How is that even possible with motors?
It's about recognizing patterns in the data.
Okay.
They're using AI to analyze vast amounts of information, not just from the motor itself,
Right.
but also from environmental sensors, historical maintenance records, and more.
Okay.
So by connecting all those dots,
Right.
they can identify these very subtle anomalies that might signal an impending issue.
So it's like having a crystal ball for motor health.
That's a good way to put it.
But instead of magic, it's data and algorithms.
Exactly.
Okay.
And the potential benefits are they're huge. Imagine, being able to schedule maintenance proactively,
Right.
optimize performance, extend the lifespan of your equipment, all based on data-driven insights.
That's a game changer. And looking at their blog, it seems like MotorDocAI isn't just focused on motors.
Yeah.
They're tackling like big picture issues like cybersecurity, energy efficiency, even the skills gap in the industrial workforce.
Yeah, they're definitely thinking big picture.
Yeah.
And recognizing that all of these factors are very interconnected when it comes to industrial reliability.
Yeah, no, I totally agree. This is already blowing my mind.
Yeah.
But I have to ask, what does all of this mean for the future of industrial maintenance as a whole?
Right.
Is this like the beginning of a major transformation?
It's definitely a sign of things to come.
Yeah.
And to understand where this is all heading, I think we need to take a closer look at the man behind the curtain,
Okay.
the founder of MotorDoc himself.
Okay. You've got my attention. Let's dive into the mind of the MotorDoc mastermind.
Yeah, watching that vlog, it's clear that this founder, he's not just like a tech whiz.
Right.
He's got a real passion for solving these problems in the industrial world.
Yeah.
And he actually talks about how he used AI tools like ChatGPT to help develop the Empower software.
Wait, he used ChatGPT to program.
Yeah.
That's pretty cutting edge.
It is.
Even for a company like MotorDoc.
Yeah.
What does that tell us about their approach?
I think it shows that they're not afraid to embrace new technology.
Yeah.
And really find creative ways to apply it.
Right.
And this whole forward-thinking mindset, it's reflected in their focus on data.
Okay.
He talks about how the industry really needs to move beyond just collecting data
Right.
to actually understanding and acting on it.
So it's not just about having a fancy dashboard with a bunch of numbers on it.
Right.
It's about making those numbers meaningful.
It is. It is.
How does that translate to like real world results?
Okay, well, think about it this way. Instead of reacting to a breakdown after it happens,
Right.
MotorDoc's approach is all about proactive maintenance.
Okay.
So you're identifying those subtle warning signs early on so you can actually schedule those repairs before a small problem becomes a major headache.
Right.
And that translates to less downtime,
Yeah.
lower costs,
Yeah.
and increased safety.
That's what I call a return on investment.
Absolutely.
And speaking of investments, I noticed he also talked about the need for better standards and guidelines.
Yeah.
Especially when it comes to like super harmonics analysis.
Yeah.
Why is that so important?
Well, right now there's kind of a Wild West situation when it comes to interpreting superharmonics data.
Right.
And so having clear standards that helps ensure that everyone is speaking the same language.
Right.
And that the analysis is accurate and reliable. And what's interesting is that this founder is actually involved in standards committees,
Oh, wow.
working to actually shape the future of the industry.
So he's not just talking the talk.
Nope.
He's walking the walk.
He is.
That level of involvement, that says a lot. But let's not forget the human element here.
Right.
He also emphasized the need for workforce development.
He did.
What did he have to say about that?
He's very aware that even the most sophisticated technology is only as good as the people using it.
Right.
And so he really stressed the need for a new generation of technicians who are comfortable with both the physical and digital aspects of motor maintenance.
So we're talking about like a hybrid skill set.
Yes.
Part mechanic, part data analyst.
Exactly.
Yeah.
So these future technicians, they need to be able to troubleshoot a gearbox.
Right.
But also interpret a data readout.
Right.
And MotorDoc is clearly thinking long-term about how to support this evolving workforce.
Yeah. Yeah. It's refreshing to see a company that understands that it's not just about investing in technology. It's about investing in people.
Yeah, absolutely.
So taking a step back,
Okay.
what's the big takeaway from our deep dive into MotorDoc?
Well, I think it's safe to say that they are at the forefront of a major shift in industrial maintenance.
Yeah.
They're combining cutting-edge technology like ESA and AI
Right.
with a deep understanding of the practical challenges that industries are facing.
Yeah.
And they're not just selling products. They're actively shaping the future of the field.
Right.
Through, their involvement in standards development and workforce training.
Yeah. They're clearly passionate about making a real difference.
They are.
And it's inspiring to see a company that's not just keeping the wheels turning,
Right.
but actually driving the industry forward.
Absolutely. MotorDoc is setting a new standard for what's possible in motor health monitoring. They're not just fixing problems. They're empowering businesses to optimize their operations and achieve new levels of reliability and efficiency.
It sounds like they're truly living up to their name, MotorDoc, like the trusted physician for the industrial world.
That's a great analogy.
Yeah.
And just like a good doctor, they're not just treating the symptoms.
Right.
They're looking for the root causes.
Right.
And working to prevent those problems before they even arise.
Well, I don't know about you, but I'm feeling pretty energized after this deep dive.
Me too.
It's exciting to see companies like MotorDoc pushing the boundaries of what's possible.
Yeah, they've given us a lot to think about in terms of the future of industrial maintenance.
So as we wrap up this episode, here's a final thought for our listeners to ponder.
Okay.
MotorDoc is clearly on a mission to transform the way we think about motor health.
Right.
If you could apply their approach to your own field, what would that look like?
Yeah.
What problems could you solve?
What efficiencies could you unlock?
Right.
And how could you leverage data to drive better decisions?
That's a great question to leave our audience with.
Yeah.
The possibilities are truly endless.
And remember, knowledge is power.
Absolutely.
By staying curious,
Yes.
exploring new ideas,
Yeah.
and taking the time to dive deep,
Right.
we can all contribute to a future where innovation and technology empower us to achieve greater things.
Couldn't have said it better myself.
Thanks for joining us on this journey.
Yeah, thanks everyone.
And until next time, keep on exploring.
You know, what really struck me about the founder's message in that vlog is how he sees data as this like untapped gold mine for the industrial world.
Right.
He's not just talking about collecting data. It's about using it to unlock these insights that can like fundamentally change the way we operate.
Yeah, he even used the phrase, data is the new gold, which I thought that was pretty insightful. And what's interesting is that MotorDoc isn't hoarding this gold for themselves.
Right.
They're sharing their knowledge, working with industry groups, and developing these training programs to help others benefit from this data-driven approach.
So it's like they're not just selling products, they're building this whole ecosystem around motor health and industrial reliability.
Right.
But let's get back to this idea of data as gold.
Okay.
What are some like concrete examples of how MotorDoc is actually extracting value from this data?
Well, think about their predictive maintenance capabilities.
Right.
By analyzing data from, thousands of motors, they can start to see patterns.
Okay.
That might indicate an impending failure.
Right.
This allows them to alert customers and recommend preventative maintenance before a small issue turns into a major breakdown.
So instead of waiting for something to break, you're getting ahead of the curve and preventing downtime.
Exactly.
That's huge.
It is.
For any business that relies on machinery, are there any real world examples of how this is played out?
Yeah, I'm glad you asked. In the vlog, the founder actually mentioned a case study where they were able to detect a faulty bearing in a wind turbine gearbox weeks before it would have caused a catastrophic failure.
Wow.
And by catching it early, they saved the company thousands of dollars in repairs and lost productivity.
That's a powerful example of how data can translate into real world savings.
Absolutely.
But it's not just about preventing failures, is it?
No.
What about optimizing performance?
Yeah, absolutely. By analyzing data on motor efficiency, operating conditions, energy consumption, MotorDoc can actually help businesses fine-tune their systems to run more smoothly and use less energy.
So it's a win-win
Yeah.
for both the bottom line and the environment.
Exactly. So they're not just about fixing problems, they're about making things run better and smarter.
And this all ties back to their broader mission of improving industrial reliability as a whole.
Absolutely.
Yeah.
MotorDoc is really pushing the boundaries of what's possible in terms of monitoring, maintaining, and ultimately extending the lifespan of our critical industrial assets.
Well, I think it's safe to say that our deep dive into MotorDoc has been a real eye-opener.
It has.
We've gone from understanding the basics of ESA to exploring the cutting edge of AI-driven predictive maintenance.
Yeah, it's been quite a journey.
It has.
And we've seen how one company is leveraging data to not only solve these technical problems, but also to really shape the future of an entire industry.
So for our listeners who are still with us, we want to leave you with a challenge.
Okay.
MotorDoc has shown us the power of data and the transformative potential of technology. How can you apply these lessons to your own field?
Mm-hmm.
What data are you overlooking? What insights are waiting to be unlocked? And how can you use this knowledge to drive positive change in your own world?
That's a great question to ponder. Remember that the future belongs to those who are curious, who are willing to explore new ideas, and who are brave enough to dive deep.
Thanks for joining us on this deep dive.
Yeah, thanks everyone.
We hope it's inspired you to think differently about the power of data and the possibilities of innovation. Until next time, keep on learning, keep on exploring, and keep on diving deep.